we're talking about discontinuous and continuous functions, and before that we were talking about monotone functions, sort of strictly increasing or strictly increasing, strictly increasing or decreasing or strictly increasing. So increasing functions are such that if x1 is less than x2, less or equal to x2, then f of x1 is less or equal to f of x2. And strictly increasing is if x1 is less than x2, that implies f of x1 is strictly less than f of x2. And we've got a similar notion for decreasing as well. So I'll just try the first one. The strictly part is another decreasing function. So x1 less than x2, then f of x1 is greater or equal to f of x2. That's decreasing. Okay. What else do we have? Oh, odd and even. So odd is if f of minus x is the same as minus f of x, and even f of minus x is equal to f of x. Then we had periodic as well. I'll put it over here. So periodic, if there exists this P element of R such that for all x element of the domain of that, we have m of x plus p is equal to f of x. Okay, so these are the definitions that we sort of talked about last week. I'll want you to have a look at the graph basically, and I've redrawn it on the board here. So ask the question on this one then. So what, if anything, is this function x that's mapped to 1 over x minus 1?
It's supposed to be 2.
Okay. Does everyone remember what continuous means? We had sort of a hand-wavy description, which is all I wanted to say about it as well. I didn't write it down. Anyone remember what sort of continuous meant?
When you can draw it without having to lift it.
That's right. Basically, if you can draw the function without having to lift the pen over its domain. So, there's an example of where we had a graph like this. So, at 0, basically, I have to lift up the pen and continue drawing this way. So this function is discontinuous. If I excluded 0, from this completely. So if I only define the function up until 0 and greater than 0, then this function would be continuous again, because basically we are excluding 0 explicitly, and on all the other points of this domain, function is continuous. So that's the definition. Okay, so
Oh, it's you that's C minus X, I think it's equals
f of minus x.
or minus of X.
Well, did you get this one?
It isn't one. It is not monotone. I think it's monotone actually.
Oh shit, channel not set.
What's periodic?
25.
right.
That's a mess.
You have to draw it.
No biscuits then. Okay. So is it continuous? Well, I can draw this line sort of continuously without lifting my pen, and I can draw this line continuously without lifting my pen. Obviously I'm excluding the one bit here, which is where I have to sort of jump, but that's not part of my domain anymore. So as such, I can draw this function continuously over its domain. So yes, continuous. Is it monotone? So is there any of these? So is it increasing, or strictly increasing, or decreasing, or strictly decreasing? No. Why not? Yeah, well, it's just basically, if you look at it, well, I mean, this one here, it's sort of strictly decreasing, but then it makes this massive jump. So it's strictly decreasing here again, but basically a point here and a point there, it's not strictly decreasing anymore. So that's a problem. And obviously for the same reason, it's neither increasing nor decreasing. So is it even? So even meant if I plug in minus x in here, so f of minus x is equal to 1 over minus x minus 1 is equal to, well, if I take the minus sign out, minus 1 over x plus 1, which doesn't look anything like minus f of x. It would just be minus 1 over 1 so it's not even. Sorry, it's not odd nor even, basically. So you can see that straight away from here as well. If it were even, that would need to be, so it's not equal to 1 over x minus 1 either. So so it's not odd nor even, and it's obviously not periodic, it doesn't repeat itself. So as such, it's only continuous. Here's another one. So we're now taking effectively the same graph we're replacing the first part with x element r, x greater than 1. So we've got everything on this side. And this bit isn't on here anymore. Okay? So what about this part then?
It's a multi-choice.
Increase
I should guess 100% gone up.
What if you make 100% of wrong answer? What if you make 100% of wrong answer? You get the biscuit?
What do you mean?
If you have 100% but it's the wrong answer, you get the biscuit?
No. 100% correct.
No, if x is straight line, x is find out what's the straight line. Only define
Well, it's continuous for the same reason that the other one was continuous. So we can obviously draw this part continuously, that's fine. And now it's also monotone because it's strictly decreasing. So it's getting smaller and smaller and smaller. All the time.
On one
What's
on
the
the
rate?
left.
So-
What's in 25? It says increasing. Or is it decreasing?
And obviously because it wasn't
Increasing
even before, it wasn't off before, it can't suddenly turn odd or even. So it doesn't really make sense anyway for this domain. There's no negative numbers allowed. It's obviously still not periodic.
Oh, I see.
Okay.
Oh.
So now we have a graph like that. And again I'll recapture this. In your mind.
Yeah, it's continuous and periodic.
It's a monotone.
It means it only goes a single direction. Or, yeah. I don't know if it goes up.
Okay? I think majority of you guys got that one. So we can obviously draw this continuously without lifting our pen. That's fine. It's not monotone. It goes up and down all the time, so it's neither increasing nor decreasing. It does all sorts of things. It is an even function because it's mirrored on the y-axis, so it's just flipped over. So if you plug in minus x, basically that just gets f of minus x is equal to sine of minus x all squared, and that's equal to minus sine of x all squared. That's equal to sine of x all squared, which is equal to f of x. And that's the end of week 9. Right. So, what's the theme? Week 10?
Yeah.
Well, that yay will soon be not good Lord. So this is basically the last part of the course, and I'll spend the next 3 lectures basically going through this in detail. And basically, you should have read health chapter, well, the remaining ones, and I'm still expecting lots and lots of questions on cellular. Otherwise, we have a very interesting Friday. Sending it on the what are we doing? But yes, we're going to introduce some differentiation. We're going to have some min-max problems at the end, which, if you look at the past papers, is when predictions going to come up. So you need to know a bit of differentiation, and I hope that even people who did differentiation at A level will gain something from this, because I'm not quite sure how you prove this stuff, but past years have shown that some of the rules that you have been using weren't really proved for you. How do we prove it? Okay, well we start off with limits, because they are the essential part that feeds us differentiation in the end. And effectively what we're looking at is how do we approach something from a side, or what does something tend to as we go to a certain limit. And that limit might be towards infinity, or it might be towards a number. It very much depends on the context. But anyway, the idea is illustrated by this example. So we've got a function that takes a natural number and maps it to 1 plus 1 over a natural number. Then we can easily see if we sort of actually work out what these values are for different n's. It starts off with 2, goes 1, and it goes on getting smaller and smaller and smaller. And the generic term is n plus 1 over n. Okay? And from that we can already see that as n gets bigger and bigger, this thing gets closer and closer to 1. But because it's always n plus 1 over n, it never gets there. However, mathematicians sort of use a sort of trick of saying, well, let n tend to infinity. And in the limit, as you can sort of imagine, the thing gets closer and closer and closer to 1. And in the limit, we just say the limit is actually 1. So as n tends to infinity, 1 plus 1 over n is the same as 1 plus the limit of 1 over n, where n tends to infinity, and 1 over something very, very big is very, very small. So in the end, basically, we're just left with 1. Okay? Similarly, we can do that with normal numbers. We don't need to jump to infinity. We can also do it with other numbers. And so I would like you to see whether you can work out what the limit is of these functions. Okay, so the first one is just normal tending to infinity. The other one, though, tends to 1. So can we figure out what the answers should be here? And you might use a calculator to work that out.
Is that going to help? That's what he said. I don't know. I don't get it. Not much what I have to do. What's the limit of infinity?
And the difference between the normal arrow and the arrow with the line behind it. Arrow. There's two different types of arrows.
One above this, just
just got another question.
Yeah, so how would you rewrite it? You can rewrite this as 1 minus 1 over 2 to the x. That's what this is basically, isn't it?
Yeah.
Okay, so if you just look at this term, what happens as x tends to infinity? 2 to the power of something very large. Next, 2 to the makes this part what? Small, big? Small. Yeah, well, the overall term gets very, very small, doesn't it?
Yeah.
So that tends towards what? As x tends to infinity, this tends towards what? Yeah. So what are you left with? What? Yep. That's right.
It's just
You do it.
It's the first one.
Third unit.
okay. Everyone should let that go.
It says if that number goes bigger,
So,
this
first thing,
overall becomes smaller, closer to 0.
this one here then.
Yeah.
How do
There's
we
one left.
approach this? Well, I would basically rewrite this first, just to give me more of an idea of what's happening. X tending to infinity of 1 minus, how can I rewrite this one? Yeah, it's 1 over 2 to the power of x. Okay? Now if I just look at what happens to this as x tends to infinity, so 2 to something very, very large, it's going to get what? Sorry, just 2 to the power of something very large gets very big. So 2 to the power of something approaching infinity is going to get huge. And you've got 1 over something incredibly huge. So that's going to do what?
Small.
It'll get smaller and smaller and smaller, and effectively it'll tend to 0. Because x tends to infinity, 2 to something very big goes massive, but the reciprocal of that, maybe 1 over this something massive, just tends to 0. So that's the same as 1 minus the limit of x tending to infinity of 1 over 2 to the x. Well, that's, I say obviously, going 0, because just like 1 over n tended to 0, this will tend to 0 even more quickly. So we're left with 1. So how about the second one then? Has anyone plugged in any numbers? Obviously I can't plug in 1. Because 1 just gives me something over 0 over 0. It's obviously not going to work. But did anyone plug in something like 1.1? Or 1.01? Or 1.0001? It's getting very close to 1 now. What sort of numbers do you get back? You going to try that? Does someone plug in 1.001? So, what's the value at 1.001? So f of that one is what? .003. Okay. What's f of 0.999? What's that? 2.997. Alright, well, looks as if you try out with some more zeros in between, you'll probably get closer and closer to, what do you reckon? 3. Okay, so we expect, for some reason, that the limit of this is actually 3. But why? Okay. Now, if you how many? Well, you must all have done long division or something at some point. You can do long division with polynomials as well. This is a polynomial. So, and what you actually find, the fact is that if you plug in 1, you can see that 1 minus 1 gives you 0. And obviously 1 minus 1 here gives 0. So what that actually means is that that this is actually a factor of this polynomial. And you can do long division. And in fact, actually, if you do that, you see that 1 minus x cubed over 1 minus x works out to be simply 1 plus x squared. So, so the way you do this basically, well, what's 1 divided by 1 plus 1? So you just work this out. So 1 minus x, you subtract that, so that gives you 0. Minus x cubed plus x. So plus x minus x cubed. So that's then divided by 1 gives you x. So that's x minus x squared. So subtract that again and gives you 0 here plus x squared minus x cubed. X squared divided by 1 is x squared. So that's x squared minus x cubed is with 0. So that's the division. So you can write it as 1 minus x times 1 plus x plus x squared over 1 minus x.
I don't get for 1, why is you divide it by 2 lots? The first one. Why doing 1 over 2 to the power of x?
Because 2 to the power of minus x is basically an inverse.
Of x depending to 1 of 1 plus
2 minus
x
1
plus x squared. If you plug in 1, 1 plus 1 plus 1
minus x
is equal to 3.
1 over 2x.
Oh,
So 2 to the power of minus 2 is 1 over 2 squared. 1 over 6.
okay.
So that's your limits. And in terms of graphs, if we look at the graph we had earlier on, so here we are approaching this, and let's call this 2 and this 1. If we are approaching this graph from the left-hand side, at 0, the function tends towards 2. If we approach it from the right-hand side, the value of the function approaches 1. So we've got the left-hand side limit and the right-hand side limit, and they might not be the same. So in this instance, the left-hand side limit approaching 0 from the left will give us 2. So this part here from the left gives us 2. Approaching it from the right gives us 1. That's what we just did. So just do a different function. So here, on the left-hand side, you're approaching it, we're getting to 0. On the right-hand side, we're coming down this way, and we're getting to 1. Yeah?
So the left and right limits only different in a discontinuous function.
That's something that we're going to use in a second. Exactly. So in a discontinuous function, basically, we'll have situations where the left and right side of the limit are the same. In this case, obviously, if I took the left and right hand side limit of this point here, even though the function is overall discontinuous, at that point, it would be the same. It's at that discontinuity where the different limits kick in. And that's basically how we define continuity. So, thank you for the nice intro for that. Basically, we didn't give that definition of continuity earlier on. We just sort of said we can draw the thing without lifting our pen. But effectively what that means is that for every single point in its domain, the left-hand and the right-hand side limit are the same. So, in a continuous function, we can pick any point and the left and right-hand side limit is going to be the same. This is a discontinuous function, and there's a point at 0 where that is not the case. Everywhere else, if you put any other point, it would still be true, but at that point here, our function has a discontinuity, because the left-hand side limit is up here, the right side limit is down here. So there's a jump. And that's basically how we define continuity. We're saying that can't happen for a continuous function. So it's continuous if and only if it's continuous at all points in its domain. Which explains why functions like therefore which explains why functions like this, which have obviously this massive jump at this point, for example, at 0, are still continuous, because 0 is not part of their domain. So the 0 is not part of its domain, so I can pick any point within its domain, except for 0, because that's not part in it, and the left-hand side and the right-hand side limit will be the same. Because even if I pick a point way down here, and my limit starts off up here, at some point my limit goes down to here and approaches it from this side, and at that point basically I've got a continuous function again. So the left-hand side and the right-hand side limit are going to be the same for the whole function, because I'm excluding that point 0. So here's a question for you. So which of these functions are continuous?
exam. I don't know how I'm going to survive an exam. Did you get it? You just mixed me and got
What is the set of views?
Set of Q's instead of all fractions. So,
oh, it might be 1 as well. I mean, no. Yeah, it will be. Because it's the 0.
That's a Q, not a 0.
Oh yeah, it's the 1 over 0.
That's one.
That's a 3 as well.
so what do these functions look like? So the first one this looks something like point here, point there, point there, and then there, and so on. Never quite reaching 1. How about the next one? So that's minus x cubed. So for x less than 0. So if I had minus 1 here, minus 2 there, minus 3. So minus 3 cubed is 27, minus 27, minus of that is plus 27, so it's somewhere up here. Then you've got minus 2 cubed is minus 8, so it's plus 8, somewhere up here. Minus 1 cubed, minus 1, everything then somewhere here. So it goes something like this. So, and obviously at 0 it's 0. And what the sine function, well, it starts off at 0 and then that's something like this. Don't quote me on the exact points here. But it looks something like that. And I'll cheat as well now to see what
Oh yeah, you can just use that. You're gonna drop out. What email is that? Your college email? Uni email? Is that university email? The university email.
Did you get your marks back?
Sorry?
Did you get your marks? For Java, did you get your marks?
The previous.
No, the first one.
The first one?
Yeah.
The formative.
No. The first one that assessed.
Ah,
Where did they come from?
did I pass all the tests? Did I pass all the tests? Or
No, today. Did you get the marks? No. I haven't checked.
No one has. They're not up. You got it, didn't you?
she said to do it later today if she managed to do it.
Same time. Oh.
I don't know, he kicked me out of the group because I made fun of him.
If she managed to assess them all, she'll send this by tonight.
Yeah, but
Otherwise, it will be tomorrow.
Did you get email from her?
I don't
What did you say?
know, but it's
No, I haven't.
I don't like touching his phone.
And -1. We have -1.
What is James?
I don't know, I kicked out the group.
What group?
The WhatsApp group.
Look.
You can't use zoom in.
It's not going to be anything.
Okay, so having redrawn these, have another go at guessing try again. Which one can I draw with all different dependents?
Did you get
their domain?
Previous one. He reset.
So yeah, let all apply.
So it's all of them. I don't even know.
Did you select all of them?
We'll see. Yeah.
It's kind of 5 when it's notepad, yeah.
You want to give us the biscuits?
He was joking.
What? It's 5. It's 5. What's the answer?
Yours getting first.
No, I've got emails to fill out.
Well, none of the above is optional. Of course, you can just draw these all continuously. You can draw this one continuously, except for that one. Now, the only odd one, obviously, is the first one. So, that's continuous. Well, basically, you've got no choice of right and left side limit because it's just the point. The left and right hand side limit of any of these points is just that. So it's by using coordinates, all of the above, all of the above, so everything's right. So good one. Yes. All of the above functions. All of the above functions. Nice try. Some more limit. So, here I wanted to look at you want to have a break or do you want to work through?
There's no words.
Hands, show of hands who wants to work through. Okay, that's the majority. Well, the first one, basically I want you to consider what happens if x is less than 0. What happens then? Or if x is less than 1. or if x is equal to 1, or if x is greater than 1, if x is less than minus 1. Have a look at whether you can see any sort of pattern that emerges here, and see whether or not you can see what happens to this value if x is in this range as n tends to infinity. Okay, so for example, if you assume x is equal to 0, well, what happens? Basically, 0 to the power of anything basically is still
0.
0.
The limit is
If x is 1, what happens then? And what happens if x is less than 1, but still bigger than minus 1? What happens if x equals minus 1? What happens at x where x is now greater than or greater than 1? Have a look at those.